All right, I'm going to walk you through how to solve these problems, and I want you to do the exact same steps with me. So we're going to go through the very first one. So number one says a simple beam concentrated load. So I want you to draw that beam, and we have a force here. So I'm going to call this force A, FA, and at B is FB, because you're holding up that beam on both sides, so there has to be a force upward on the left side and the right side. So we're going to call that A and B because the left is A and the right is B. We also have a force down, that's P, P1. And from the instructions above, now that we've drawn our picture, from the instructions above it said that P equals 500 pounds. So we can write that down also. So the first thing we need to do is we need to sum. So this little sign there means sum. We need to sum our forces, and they are always going to equal 0. So that means that the forces going up have to equal the forces going down. So what I can do is I can say, put a little arrow there, say that FA plus FB will equal P, and in this case that's 500. So I don't really have to do anything more for that one. I'm just going to put a box around that. That's done. So check, we've done the sum of the forces. The next thing we have to do is do a sum of the torques. And torque is force times distance. So I'm going to write that up here. Torque equals force times distance. And right now we have our force, a force, and a force. And from the picture, it also gives you those distances. This is a distance of 0. This is a distance of 16, and this right here was the distance of 4 feet. So we have a force and a distance, a force and a distance, a force and a distance. So we just multiply each of those and add them. Now, since the upward forces are pointing up, they're going to be on one side. So this is kind of supposed to be an arrow like that. We have FA times, and that distance is 0. So FA times 0, force times distance, plus FB times 16, and they equal the downward forces. So in this case, we only have one downward force, and that force, remember, is 500 pounds times 4 feet. So you can see clearly FA times 0, that's going to be 0. That cancels out. So I have 16 FB. I like to put the 16 first. 16 times FB equals 500 times 4, which is 2,000. And then if I divide by 16, then FB equals 125. So I'll put a box around that. So I know FB is 125. Well, then I have to go back up to here, and FA plus, now instead of FB, I can put in 125. So FA plus 125 is 500. Subtract 125 from both sides, and FA equals 375 pounds. And I need to make sure I have units on there. Pounds. So hopefully that makes sense. FA is 375 pounds. FB is supporting 125 pounds. If you look at your picture, FA is over on this side. The force, that point source, is a lot closer to FA, so it's supporting more. FB is supporting less. So it makes sense that FA is 375, FB is 125. If we add them together, we get a total of 500 pounds. So it checks out. So that is an example of how to do the first problem. Let's take a look at the second one. So once again, we want to draw a picture, draw the beam, draw the force, FA, and that is at a distance of 0. FB and that's at a distance again of 16. And we have our point source P at a distance of 11, in this case, 11 feet. And we also have something different in this one. We have this uniform load, and that is called W. So we've drawn our picture. Now we write down what we know. We know that P equals 500. We also know that W1, they're calling it 1, is 100 pounds per foot. So since it's 16 feet long, we multiply this by 16, and we get a W of 1,600 pounds, because it's 100 pounds per every foot. So it's 1,600 pounds for 16 feet. So now we do the exact same thing we did before. We do the sum of the forces. And I have a force here, 1 force, 2 force, 3 force, and a 4th force. So we have to now take into consideration the weight of the entire beam. And we also have to figure out the location. Well, if we have a uniform weight of an entire beam given with all these little arrows, the location is always right in the middle. So I'm going to draw that as a thick line, and I'm going to put a dotted line and do an 8. So I can see a distance. I have 4 distances, and I have 1, 2, 3, 4 forces. That makes it really easy if you identify things up front. So my sum of my forces, I have FA is going up, FB is going up, and my downward forces are W and P. So it has to equal the downward forces, which are W is 1,600, P is 500. So I have FA plus FB equals 2,100. That's my first equation, so I'm going to put a box around that. The next thing I do is I have the sum of the torques. Remember, torque is force times distance. So I have FA at a distance of 0, always going to be 0 because that's where we start. FB at a distance of 16. Hopefully that sounds familiar because it's at the far side. It's 16 feet long. And this time, my downward forces, I have 2 of them. I have a W force of 1,600 pounds times the distance. Well, the distance is 8 feet. Uniformly located weights are always approximated in the very center, so that's always going to be an 8, or not an 8, but just halfway between the 2 sides. In this case, it's 8. Plus my P force, which is 500, and that was a distance of 11. And that becomes 0 plus 16 FB equals 12,800 plus 5,500. And let's keep solving this. If we add these two together, we get 18,300, and then divide by 16. And FB equals 1,143.75 pounds. So I'll put a box around that, and then we go back up to here, and we can say that if FA plus, and now I know FB, so I can put the actual number in there, 1143.75 equals 2,100. Subtract this from both sides, and see that I'm writing everything out. It really doesn't take that long to show all your work, but it makes it a whole lot easier to see what's going on. When I subtract these, I get 956.25 pounds. And then I put a box around that too. So it's very easy to follow my work when I show all of my steps and I show everything that's going on. But right now what you can see is I have solved for FB. It's 1143.75 pounds. FA is a little smaller, and that should make sense because I have this point source that's closer to B, so it's supporting more load than A is. So that's an example of how you do these two problems. As you look at your assignments, you're going to find they may not be more difficult as you move on. In fact, number 3 simply has a uniform load. It does not have a point source. So that's a problem where you're only going to have one force just at 1,600 on the side. Problem number 4 has 2 point sources, And problem number 5 only just has a point source and not a uniform load. So you're going to find out just because they're numeric, 3, 4, and 5 doesn't mean they get more difficult. It just means they're different types of problems. You may even find that they're easier than some of these. So go ahead and give them a shot, and I need to see your work just like I've shown mine here.